Hello and welcome to another episode of Cloud Security Podcast with Virtual Coffee with Ashish. And we are back again once every week. We talk about cloud security problems. And if you are new to this channel, consider subscribing if you are into Kubernetes security, cloud security, and anything related to cybersecurity, really. And I see Magno's already here on the YouTube stream. Thank you for coming in, Magno. Before we get into the stream and before we start talking about attacking and defending managed Kubernetes cluster, which we'll get into shortly, I need to thank a few people who have been responsible for making this show happen. I'm going to start with Exonius and then BreadCrumbs, and I'll see you back in a second.
Hey, Ashish and Cloud Security Podcast listeners. Thanks for giving Exonius the opportunity to sponsor the show. Exonius does exactly three things. By connecting to existing data sources, Exonius gives customers a comprehensive asset inventory, both cloud and on-prem. It then uncovers security apps, and finally, it automatically validates and enforces policies. Thanks again, and check us out at exonius.com.
BreadCrumbs is the all-in-one cloud security platform for developers. BreadCrumbs analyzed thousands of open source Helm charts to bring you the newly released State of Helm Security Research Report. Learn their security insights and more at bridgecrew.io/CSP. Awesome. And thank you so much for the sponsorship. It really makes us, I guess, run the show and bring some amazing guests as well. So I do appreciate it. Now, it's the moment you were waiting for. I'm going to put the music on the cue. Hey, Brad, welcome.
Hey. Thanks for having me.
I was like, I hope people got the song. I truly hope people got the song. So as to what the song was, in case people are wondering, it's like we didn't start the fire. If you are a young one who probably doesn't know the song, you should definitely Google it. It's probably one of the greatest songs of our times, I guess. Well, welcome first of all, and it's a tradition. So cheers, man. Thanks for coming in.
Yeah, cheers.
Thank you. You need to tell about the other cup as well, and what are you drinking?
So this is my son Henry's souvenir from visiting Orlando. It was just a fun cup, and just some iced tea. It's not really iced anymore. It's more like just cool tea. But yeah, I got a little caffeine before.
Appreciate that. We definitely need a bit of caffeine to kind of get going. So I'm gonna start with. I know a bit about you. I've been kind of I guess online stalking you for some time, but a lot of people may not. So who is Brad, and how? I mean, I guess where are you professionally now?
Yeah,
how you got there? I guess.
Yeah, I guess the easiest way to say it is in short. I've been in the space for almost 20 years now, but SOC engineer, pen tester, security architect, sales engineer, security consultant, and in the last 5 years or so, building ethical hacking training scenarios. Later, it was on VMware, but then on Kubernetes, and that was in 2016. And ever since then, I've been in the cloud native, container security space, specifically with a lot of Kubernetes focus. So, this past year and a half now, co-founder of Darkbit and doing cloud security posture assessments for companies running and focusing on Kubernetes, specifically in GCP and AWS and those managed offerings. So, just a small group doing some deep dive expertise stuff.
Awesome. And I think I'll definitely recommend checking out the Darkbit website as well. You guys did a great job of making the attacker first mentality stand out there. So kudos to you guys for that. But
Thanks.
What I've realized after, I guess, running a whole month of Kubernetes interviews, and the last 4 interviews over the last 4 weekends have been amazing guests. We've spoke about Kubernetes, and I kind of wanted to get some of your perspective because you also bring in a bit of a holistic perspective as well. As you said, you've done SOC, you've been a pen tester, you've done kind of different things. I'm gonna ask two different sides of the same puzzle. I guess. Okay. What does cloud security mean for you?
Cloud security, being a pen tester in the 2008 and before era, so Windows 2008 was the latest at the time. So sort of stopped there. There was sort of a specific set of responsibility, and it was kind of common. Everybody's running everything. They're running their run books to build their Windows servers and things. I think cloud security to me is having tiers of shared responsibility for different workloads. And so as a security professional or as a defender, as an attacker, it's not just, here's the infrastructure, here's the data center, and this is how you get, there's different models for each one, things that cloud providers are responsible for, things that you're responsible for. And if you're running a VM versus a container in something like Kubernetes versus something in serverless, I don't want to say they're worlds apart. That's not fair. They share a lot of substrate, but from what am I defending? What am I looking for? What am I, trying to do a response process on? They're worlds apart. They're very different. So to me, it's a combination of all those things, depending on what you're running, and adapting all your processes to the various sets of shared responsibility.
And I'm glad you brought this up about the various process and shared responsibility, because I almost find so many similarity between that and Kubernetes security. So what about Kubernetes? And for people who don't know Kubernetes, I think after running a month of Kubernetes in Cloud Security Podcast, I'll be surprised people don't know this, but what is Kubernetes and what is its relevance to cloud native?
Yeah, it's a great way to run other people's code next to your secrets and data as root. That's a quote that Ian and I came up with at our RSA/KubeCon talk, because it was like, when you think about it, it's really, depending on how you run it, it could be considered remote code as a service, because if you're not taking care of things, that's where it is. But from a Kubernetes perspective, it's like, it's like, why would you use Kubernetes? Like, what, that sort of fits into this question too, I think, is like, you're running infrastructure and you have patterns that keep repeating. And because you are running enough infrastructure, you tend to be at some scale where you're like, we're doing this the same way, or sorry, differently, but for the same types of apps across our infrastructure, we should be doing this in a more common way. That's typically when you're ready for something like a container orchestration platform that says, this is how we do load balancers, this is how we build images and how we ship artifacts, and this is how we deploy, this is how we test, and this is how we validate. And all the things that come with it have to adapt. And so all the security aspects and the policy and the response and things follow suit. But it's that's what I think of when I think of distributed containers, distributed bundles of shared processes and their shared dependencies on multiple hosts.
Is that what would become cloud native as well?
I think that's one aspect. Like, cloud native is to me, I think people use that definition quite loosely, but it's back to the shared responsibility. But if you sort of step back from it, it's leveraging that level of control versus shared responsibility and ownership to the maximum advantage for that given workload. So if I had this thing that just needs to respond with the IP of who talks to it, like ICANN has IP, I could do that in a serverless container I don't have ops, I don't have to work, I just push to it and let it run. I don't have to do as much. But then there's something like, this is my core business, I have a very custom driver, or I have a thing that is different, that is my secret sauce, I need control over it. You might take it down to, a containerized infrastructure or even a VM infrastructure just to have max control over it and that granularity.
Oh, I love it. And by the way, I just want to quickly shout out to your support crew that's currently came in, which has got Dan Pop in here as well.
Dan.
And I've got Magno as well out here supporting you. I saw your question as well, Magno. I'm going to I do have that question, so I'm going to come to that in a few minutes as well.
Okay.
But we're talking about attacking and defending. And I do feel the best way to learn security is to learn how to attack it, and then you kind of, maybe this is how should I defend because this is how I'd attack. So starting to talk about attacking Kubernetes security, like what's usually your approach for pen testing Kubernetes kind of clusters? Yeah,
it's funny using the literal word pen test is, I argue that something like and this is going to sound self-serving, but a security posture assessment would be akin to a vulnerability assessment that you might do ahead of a full-on pen test to validate that you fixed a lot of the low-hanging fruit and things. I argue that a security posture assessment where you're looking at the config and metadata is step one, and then pen testing is a validation of that process. So like from a config standpoint, I'm looking at external attack surface. How are the nodes exposed? How's the API server exposed? Are the components that run your cluster exposed? Which apps are exposed via load balancers, and sort of that attack surface, right? And then stepping inside the cluster, then it gets very interesting because running as a container, what things do you have? What permission do you have? Do you have RBAC access to the API server from the pods? Do you have network policy that's preventing you from moving laterally and moving around inside the cluster? How well are you preventing or defending access to the metadata, typically associated with cloud instances? There's credentials in that metadata that give you access to the broader ecosystem. So there's kind of different scenarios. So the outside in is pretty straightforward, and whatever apps are exposed, then you sort of move into your standard web app or application security models from that point, because you're looking at the API interfaces and authentication, authorization, that kind of stuff. But when you're inside the cluster, it's like I always envision the what if. Like, what if a container is compromised and I have a shell on, just pick a pod, that pod. What's my worldview? What things can I see? What things can I do? Can I gain access to credentials that are sitting there? Can I hit other services inside the cluster that are, different teams or different, namespace, that kind of thing? And just seeing where that lateral movement happens, because it's quite common, unfortunately.
Oh, I love what you said. So it's almost like giving you a viewpoint from the pod, but also, like, I guess to your point, there's two views. One is from the outside in, where this is where you hear about that Tesla API server issue, or I guess not issue really, but like the use case that happened over there. I think offline we were talking about that Team TNT one as well. Was that similar?
Yeah, shout out to Magno and folks at Trend. Really nice blog post a couple days ago where they're talking about sort of a more sophisticated, I wouldn't say like incredibly sophisticated, but more sophisticated than what I've seen in the past, attacking the kubelet, the old kubelet exploit, which isn't really an exploit. It's just kubelet not having authorization enabled. And so, tools and techniques that are taking advantage of that, and then pivoting and scanning and trying to hit other kubelets, and then run a Monero miner and using IRC to communicate, et cetera. So that's some interesting things that are happening, but that's sort of attacking. That's why I say that first step is, what are my components? Is my SSH on the nodes? Is kubelet on the nodes? The API server on the control plane nodes? Are those exposed externally? Because that's where that attack stops from the outside in. That doesn't mean it can't happen from the inside to the inside, but just from my mass scanning the internet and I see a port 10250, it's probably going to be a kubelet, and you can ping it just to see if it has authorization disabled really quickly, and it's high confidence and low effort from that point.
Interesting. And so we kind of went into the recon phase as well when you were talking about what does your view look like from the pod out and what else you can do. And because there's so many services within, like, just pick a component. You pick a control plane, so many components over there. You pick a node, there's so many components over there. Yeah. Like, what are some of the low-hanging fruits that people should be kind of looking for, which are common?
Yeah, absolutely. So that component configuration I talked about, I'm talking about like the flags on the API server, the flags on the kubelet, and those types of things. Yep. That's step one. Step two is probably RBAC. I know of someone, I'm not going to name them, but they have automated scans using mass scanners that trigger on API servers that hit API v1 secrets, meaning there's a misconfiguration of RBAC. And so if you see that, it's RBAC isn't enabled correctly, or somebody purposely opened that door, and that means basically you're cluster admin in that cluster. So RBAC misconfigurations is the second thing. Just reduce the amount of stars on the RBAC policies. Then it's admission control, network policy, and then I would say secrets management. And admission control being the biggest thing that prevents a developer from becoming your lead SRE in two commands, right? You want them to stay in their namespace, or you want them just to work on their workloads. You don't want them to be root on all your nodes just because you allowed them to run a host path root pod or something like that. So that's where admission control comes in.
Actually, that's a good point, because that just reminded me that in the first few conversations that we had, we kind of went into API services low-hanging fruit. We even spoke about, I guess, container security as a low-hanging fruit as well, depending on where you're downloading container from. Yeah. The RBAC is something that we haven't really spoken about, because we spoke about network policy and pod security policy as well. But I'm curious about the whole RBAC piece here. Mm-hmm. When you say RBAC, is that more RBAC for the node, or is it for the cluster itself? Like, how? I mean, you don't mind unpacking that a bit?
Yeah. So the Kubernetes authorization mechanism is role-based access control. So the API server. So can I get pods? Can I list pods? Can I create pods? Verb, resource, right? And so when you're creating cluster role bindings or role bindings, which are namespace specific, you're granting specific API actions to a user. And if you're giving create pod or view secrets, you're giving very powerful verbs. You're giving them lots of access by default. You need to actually, for the create pods specifically, you also need to have admission control to back that up. So yes, you can create a pod, but it only looks this shape. It's not a very privileged one that escapes to the node. It just does the web server, or it just does the caching tier or whatever it's supposed to do, right? But the view secrets is the one that is often hidden in stars, meaning a Helm chart. I'm not picking on Helm chart specifically, but often what happens is somebody installs a Helm chart and doesn't audit what is happening, and they're installing cluster role bindings to be able to make the thing work. The operator, the GitOps operator, the thing that's deploying things on your behalf, will typically be cluster admin. So it'll have a cluster role binding of like verb star, resource star, right? And so you're just giving it full access to everything inside the cluster. And where I see that sort of overlap is, and this is actually a real use case from one of our clients. They had a GitOps operator, so something that's responsible for deploying, and it has to have its privileges, no doubt. And it was in a separate namespace. And then they give view secrets, because they were using sealed secrets, in this like front end web namespace, we'll call it. But what happened was that there was a performance problem, and they wanted to break it out. So they installed multiple versions of these, one in each namespace, and it just handled its piece. But what happened was then that crossed over. So the developers had view secrets, and they installed the GitOps operator in the same namespace, which installs a cluster admin bound service account. And service accounts are stored as secrets inside that namespace. So they basically gave them access to a cluster admin token. It was a complete oversight. There was like, oh my goodness, had we realized that there was that crossover? That's what I mean by that misconfiguration. It's really easy to install multiple operators and then just go, wait, I'm just giving them, they're viewing secrets in just that namespace. It's totally fine. Yes, on the surface, but you have to look at what else is inside that namespace to make sure it's not a secret that contains a cluster admin bound service account token. And that was like the one step for the developers to become cluster admin. And then you have other tiers where it's like, now that they're cluster admin, they're basically root on the node. So when you think of cluster admin, think of root on the underlying node, because you can bypass policies, you can take off pod security policy, you can disable admission control. You can clean logs as well. Once you're cluster admin, you're able to access all the credentials that are attached to all the nodes. So if you have cloud metadata that maybe makes the control plane nodes, and this isn't going to happen in managed clusters necessarily, hopefully it shouldn't. If you are able to run workloads or get access to the API server or the control plane, typically those have higher IAM privileges in your cloud environment. Things like creating VMs, attaching disks, doing also like having full control of some aspects of IAM for that account. That's where it gets very, very interesting. So you have a two-step misconfiguration here. You have the ability for a user to see secrets, which makes them cluster admin, which makes them ownership of all the nodes, which makes them ownership of all the credentials attached to the nodes. And that's how you walk and escape out of the cluster in a lot of cases. So that's like an example of like how you think, why I think of, this pod as the starting point, because it's either compromised from a web app, like it's a front-facing web app and it gets compromised, attacker has a shell, or its developer is kube control execing and feeling malicious today. They woke up and they chose violence, or it's a malicious dependency that comes in from your container and it sits there and now it's running. All of those start from I'm an unprivileged container or pod inside the cluster, and by that I mean like it's just sitting where what can it do? Does it have access to tokens? Does it have access to network? Where is it going? That's why that scenario is so common in a lot of the Kubernetes security talks. You're like, let's assume that the attacker has a shell in the pod. That's because that's the start of so many of the scenarios.
Right. So in a way, it's probably your Achilles heel in a lot of ways. it gives you it is something that you need to function, but is also part of, I guess, the beginning of attacks. But maybe another way to put this is sorry, were you gonna say something?
No, I said yes. I said I agree.
Perfect. Now I was gonna ask in terms of with the managed cluster and unmanaged cluster, maybe if you can start with the difference between the two, and would the low-hanging fruit be different if to your point, if it's a managed cluster in a cloud environment, but say GCP or AWS?
Yeah, so a managed Kubernetes run by, say, a cloud provider is typically, they make the dividing line that they don't give you access to the underlying nodes of the control plane. The control plane being things that run the API server, the controller manager, the scheduler, and etcd. Because if you can get access to etcd, and this is not very common, but it's just, that's the database, right? So like think of the analogy of a web application and it talks to a MySQL database. Well, if you could just go into the database and go, yeah, the record is XYZ, the web server will trust it. And so, you can make yourself admin. If you just go admin equals true in a select statement, then the next time you access the web, I was like, yeah, you're admin, right? Similar thing. etcd is the backing. So you never want to let anybody get to etcd because it stores the secrets. And it stores all the configuration that would give you the ability to become cluster admin. So they take those keys away from you. They don't let you have access to those for very, very good reason. So they give you access to the nodes because that's typically where most workloads might need something, like you need privileged access to a GPU or a container storage interface driver that's doing something cool with, fiber channel or whatever. That you need a little bit more control. You can give them root on the nodes, but not the control plane nodes, just the worker nodes where the workloads run. And so if you are running your own Kubernetes, like if you're running something like Kops, I'm not picking on Kops because you're managing that control plane, you have to be very careful not to allow workloads to run on the control plane nodes. You have to worry about the API server. You have to protect it from rate limiting, denial of service attacks, all that things. If you expose that API server, you own that responsibility of the most important pieces of your cluster. So if you're saying, I don't really need that much control over the control plane, I'm happy to give that management up to AWS or GCP, by all means do that. It's worth the $100 some odd a month for a cluster because their SREs are handling that for you. They're patching it. They're taking a lot of extra precautions that you don't have to. So then your focus as in a managed cluster, you're focused on my node security, and you're making sure that workloads don't interact with each other that shouldn't, not also roping in all the stuff that you need to do necessarily to protect that API server and etcd and things.
Interesting. So maybe how about we scale this? You know how cloud is all about, let's scale everything. Let's just make it like 20,000 deployments in a few seconds. So if we talk about multiple nodes scenario, and I'm thinking in my head, it's a managed cluster. I've got obviously a pod definition, a pod template that I've defined for the deployment, which only has one node, but I've got multiple nodes. How does this attack scenarios kind of scale? Like, what are some of the examples you've seen in terms of like a large Kubernetes deployment in a managed cluster context?
Well, so I mean, scale is in vertical, horizontal. It's like how big your pod is, like how much CPU and resources, and then how many there are. So just in general, I mean, scale can go really big really quickly. I've seen somebody go from a 10 replica deployment to 1,000 replica deployment, and I've seen that node auto scale and eventually topple under its own weight because it wasn't configured correctly. But it can do that with the right help. So if you're setting requests and limits correctly, saying my pod uses 1 CPU and 1 gig of RAM, and I'm correct when I say that, Kubernetes will handle that for you very gracefully. What's interesting from an attacker's perspective is the privilege you get by being cluster admin means you can be extremely efficient at then getting access to all those nodes, because the kubelet and the API server are fundamentally an in sync. I'll run this command for you. It's either a container or a new container or a command on the host. So you can if you get cluster admin, you have access to all of that through a wonderfully documented, multiple client library API that lets you get access to everything that's in the cluster. So kube-control is your best friend, but you can write any code that you want. If you get cluster admin, if you have the permissions, you can be extremely efficient at moving around and being a part of every single node and seeing what's on every single node. And I think that's sort of the fun aspect of it too, is like using the control plane. If you get those permissions, using it as an administrator would, because then you blend in, number one. And number two, because it's the most efficient way to harvest all the secrets and all the data from all the nodes, is to use its own literal orchestration against itself.
It makes me smile because I'm just thinking, what about, how it's interesting that the cloud provider takes away access for APIs and probably most of your control plane. But if you're still cluster admin, you definitely still have, like, you're scaling your privilege across the node, but just have a crypto miner in all of them. But maybe let's just talk about maybe multiple clusters then, like in terms of like the whole lateral movement and everything. Like what are some scenarios over there, and how would you, I guess, abuse them, for lack of a better word, in a managed cluster?
Yes. So I'm a big proponent of considering the cluster. Like the multi-tenancy debate, there's really not a lot of accessible or easily used hard multi-tenancy where it's like untrusted code is okay running inside your cluster. There has to be some level of trust. And typically soft multi-tenancy is like this team in my organization and this other team in my organization, who I have legal control over. If they do something nefarious, that is typically what we're talking about by multi-tenancy. But there's still blast radius. And what you just described as, this whole scaling thing, I don't want necessarily to have one compromise make that attacker have cluster admin and route to everything in my entire organization. Just for fault domains, just for regional outages, or most likely, availability zone outages in a cloud provider, you might want multiple clusters because they might be different shapes too. I might have a GPU workload over here. I might have a batch jobs workload over here. I might have my front end. But those things should never touch. This is touching back end data lake customer. Don't share that in the same one that is front end accessible, that runs my .com website or my API that I let anybody in the internet use. You want those separated. So I see using clusters as the blast radius of this. Think of the similar mindset of why would I put VMs in a different VPC? Well, these are my dev instances. Well, these are my prod instances. Well, draw a dotted line around that VPC and say, these things go together. That should probably be in the shared cluster. Maybe not, but definitely should not be in the same cluster over here, which is the dev things. Definitely should not be the same thing over here, which is my data lake thing. Like, that's how I look at it. So sharing, or I should say separating that blast radius by separate clusters is the best way to go. And in GCP specifically, I always give the advice of one GKE cluster per project because there's too many opportunities for IAM crossover. Compute admin gives you actually access to all the nodes underlying GKE because they're just GCE instances. Like those types of things you don't really think of, like the shared logging patterns where all the logs from all the clusters go to the same logging destination. Those typically are things that you might not want shared across teams or different things. You wouldn't separate those in projects. So in AWS, it'd be different VPCs and different CloudWatch, and then in GCP, it's in different projects.
That's a good advice, actually. And thinking about all the cloud providers, which actually default have footprints collected as well for everything that you're doing. And I'm just imagining a scenario. I took your advice. I started looking at how do I become a cluster admin? I became a cluster admin, and I'm trying to deploy clusters across the board. But what's my get out of jail card? I guess, how do I delete my footprints?
How do I what?
How do I delete my footprint for or the breadcrumbs that are left behind? Is there things that I should be looking out for in Kubernetes clusters that record me doing things, I guess? How would I remove that? Or what should be my thinking there?
So like you're an attacker, right? And you're leaving breadcrumbs, or you're a defender and you're looking for breadcrumbs. Like, if you're an attacker, there are if you're running in managed clusters, typically, if you're configured correctly, in other words, you're sending the audit logs from the API server and you're shipping logs from the nodes, most times that's done for you. It might not be perfect, or might not have enough granularity, but you should be able to quickly enable that. That is one of the key things that is different in a lot of environments, that an attacker can only delete what's on the nodes, and they might not be able to delete what's in the control plane because it's already been shipped off. So as how do I clean up after myself? It's really hoping that the organization is not looking at those historical logs after the fact, right? That they're just like, oh, they're live troubleshooting and they don't see anything, so they don't know what's going on. But the record has already been, logged off and said exactly what happened. This was the manifest at this time from this service account, et cetera. So I look at it like there's only so many things you can do to delete the breadcrumbs. You can just not show up in a kube control, get pods or get resource or whatever the item that they're looking for. But if you're auditing the right things, you're like in EKS, there's 6. You have to enable them explicitly, right? You want these you want those shipped off. GKA will do it, but you actually need to add additional ones to get all of them. It can be verbose and it can cost extra money, and that's why they're always like, well, these aren't on by default because it costs a lot of money. Well, that's your literal record of what's happening inside your cluster. It's another API with all these features. You want every request and every chance you get of what's happening. You want that shipped off the cluster for you automatically. Then the breadcrumbs are hard to delete because they're already gone. They're already shipped somewhere safely.
And to your point, if those 6 options were not selected, then probably not being logged anyway. So yeah, you've already minimized your breadcrumbs to begin with.
Yeah, like I'm not picking on EKS specifically, but in a default situation, very little is logged from what's going on inside the cluster. So there's a lot of chance to be silent and stealthy. But if you turn those on, it's going there unless you start getting access to go delete those logs from where they're stored, like in S3 or in CloudWatcher, those types of things. Like you have to go another step further to go delete those logs from the record.
Oh, I love what Magnus said as well. No log, no crime.
Yeah.
That's
no
so
gosh,
true,
no
man.
system masters. Yeah.
Yeah, that's right. And maybe another few layers that I've always considered from an attacker's perspective, and keen to know your thoughts on this as well. With the SSRF and API metadata that exists in cloud service providers as well, and all these services that are being produced, like the supply chain of Kubernetes as well, like a lot of people deployment would, let's say, I'm going to use a CI/CD pipeline to create my container for a container image, and I'm also going to create one for create a CI/CD pipeline for a Kubernetes cluster as well. Mm-hmm. We had Mark Manning earlier in the month, and he was talking about a cluster where 3,000 developers were logging into one cluster. And I'm like, oh, I imagine that in a cloud context, and I'm going, oh my God, this is insane. But what are some of the other moving parts in a managed cluster that people can also look at for either from a Recon perspective or possible exploits, I guess?
Wow, that's a loaded question. There's a lot there. To your point about what Mark Manning said, I love Mark. Just in general, I'm a big fan of not allowing, and this is part of like a maturity journey. If you can get to a point where your developers, only your like 5 or small number 10 SRE, cluster admins, whatever infrastructure platform teams, those are the folks that are using kube control in a break glass scenario, like, oops, something's really sideways. Let's go debug this. If that's the only time you're using kube control, that is an optimum state. If the developers are literally interfacing with a code repository that says, I want to bump the version, I want to check in code. Once it gets approved, it gets put in a testing branch, and the automation takes it from there, and they don't have kube control, that takes a ton of complexity out of the problem. That takes a ton of attack surface, because RBAC, while extremely granular, is incredibly hard to do temporally. I know there's some solutions out there, but it's like you either give them it's hard to do like I need to break the glass for this one time type of access. It's like you give them create pod, you give them view secrets, and that's that. That's the RBAC is sitting there. There are some identity proxies that can do some fun things there, but that's a lot of complexity just for this. But if you can get the developers not working inside the cluster, not caring about that level of abstraction, you're winning, because then you can change things out from under them in a good way. Like you can upgrade your clusters, you can move things around, and they don't have to care. And that takes away a lot of attack surface of, giving them that access. What that means, though, is that you have to give them the tools, the feedback loops, the observability to feel just as confident about that deploy if it goes sideways or if it's working or is healthy as you would if you got it from a kube control command. It's like a cheat. It's like, oh, I can see it with a kube control. That's why we need it. And you're like, no, you need to see that deployment is healthy. You don't necessarily need to run a specific kube control get pods. So if you can get them out of the cluster, you reduce the complexity of, I can't imagine 3,000 developers in RBAC. Oh my goodness. Be one massive group, and it's probably like cluster admin. Boom, there, we're done.
That's right, everyone.
Yeah, because it's hard to manage that at scale, right? So
yeah, and I wonder if that's a debate as well. Like a lot of security folks maybe are talking to SREs or kube cluster admins, whoever you're going to call them, where everyone is probably talking about, and for context, kubectl is kind of like the SSH of the world, for virtual machine world, for people who may be listening in. A lot of people do ask for kube control because that's what all the guides online talk about. That's what everyone talks about. And suddenly security people become the bad people because you don't want me to have kube control. I'm like, well, that's why CI/CD pipeline, because that's why you go through there and that's how you test it. That's why you have the dev environment, test environment. So I hope people have healthy debates about this and how they land on this. But that also is a good segue into probably talking about more on the defending side of things as well. Then maybe we'll start with something simple and say, we're a startup and we're thinking about, okay, we're going to start with Kubernetes. But the first question is Kubernetes right for everyone?
No, it is not. It is I love it because, I love it because of a lot of reasons, but once you get it, it's hard not to see that pattern everywhere and want to apply it everywhere. If you don't see those patterns done poorly first, you might not understand why Kubernetes was written the way it was, right? You're declaring state and then letting it do its thing. It's not you're imperatively, like you're acting on things, the commands must be in certain order, et cetera, and then it works. It's make this pod. I don't want to have to know anything more about the implementation details. Store this secret, store this config map. Like that is a clean way. And then once you step back from it, you're like, well, gee, it handles load balancing. It does this. It starts making standard patterns that apply to all these problems. But you might not be big enough or have those scale patterns that require it. You might just be like, I just need 2 VMs in an auto scaling group. I just want at least one up. And I want it to talk to this RDS instance. Perfectly reasonable 3-tier stack. Like, do that thing. If that is the simplest thing that achieves your goals, great. But if you have 50 of those and they start to drift a little bit, or they start to have, these 10 get upgraded, but these take a little bit, you start going, well, gee, we're having to run across all 50 of those things and do the same things over. Wouldn't it be great if we had a standard VM that does this, and we'd have a standard way we'd set up our databases? And you're like, gee, it'd be really cool to have that in like a little snippet of YAML, and we could just say, go make the thing. That's where, Kubernetes, there it is. That's why you like see that pattern and it comes to that. So maybe at a startup, your focus is on getting traction, getting customers, getting users, whatever technology it is to do the thing. It's not, let's build it on Kubernetes and then they will come. That's not going to happen. So I would argue you will know when you're at that problem space, when you start seeing those patterns of doing things poorly across multiple sets of infrastructure that are like, man, we do everything kind of the same, but not really. It'd be really great if we standardize this. That's when it might make sense for a container orchestration system.
Interesting. And I'm thinking about all the large enterprise that may be listening into this and going, well, it's too late for us. The horse has already left the barn.
Yeah.
So for lack of a better word, so for people who already have Kubernetes clusters in their environment, thinking about them for a second over here, maybe is this right for them? Maybe because they're, to your point, they're at that scale. They've been doing some container orchestration for some time.
Yeah. So Kubernetes has a funny way of bringing out organizational problems, whether you like it or not. It covers so many areas. It covers networking. It covers load balancing. It covers VM patching. It covers container build pipelines. It covers security. It covers auditing. all these things are collapsing into a shared infrastructure. So if you have pain, it's going to be where you're weakest, and it's going to bring it right to the forefront. You're going to have, what do we do with these logs? I don't know. Where do we ship these logs? Well, we never really shipped it to one central place with a standard way. Not all of our applications log the same way in structured JSON. Well, it's going to bring that right to the surface, because you're like, how do I debug this thing? Well, this app sends it like in syslog format, and this one's, oh, now we have to solve that. Now you're bringing all this technical debt that you should have solved or should be in the process of solving before you get to the point of Kubernetes. But if you're already on Kubernetes, it forces you to be good, or at least a decent level in a lot of areas that maybe you weren't really ready for. And it then changes things on top of it. So the security team is, we always like to pick on, like, what is Kubernetes? I guess we have some of those in our infrastructure. How do we pen test it? How do we red team it? How do we defend it? I don't know. Like, they're having to relearn a threat model of a completely different way of organizing infrastructure. And how do you defend that? How do you attack it? How do you do incident response on it? All those problems surface because maybe you weren't really good at doing that on standard VMs or standard bare metal, and now you're doing it, and you're doing it in something that has moving target, pods come and go, nodes come and go, load balancers load balance to nodes, and then they don't load balance to other nodes. And what happened when? I don't know. We never really kept good it's a trickle down effect of, if you're not doing all the right things, you're going to feel that pain. So people perceive a lot of complexity with that because it's relearning and rebuilding muscles that maybe you never had, or you did differently or did poorly. But if you do them correctly, if you follow the happy path and you do, well, I'm just going to send all the logs to CloudWatch. I'm going to send all the logs to Stackdriver, and I'm going to install Falco, and I'm going to do this. I'm going to install this admission control. If you start doing the things right, you start going, oh, I get it. I see it. I'm seeing why this is, and I'm going with that happy path. You'll be better off for it. And I think your organization will need to mature in all those buckets. Like, all those categories you can't have a bunch of immature buckets and then a bunch of mature buckets. You have to bring them up. Otherwise, you're going to feel that pain.
Oh, I love it. And I think to your point about, in all of that amazing gems you dropped in, the one thing that stood out for me is that things that used to be individual roles in a threat model, now they're combined in many cases. Yes.
Like, what is like the role of legal in your software bill of materials? Like, are they looking for GPL or LGPL? Well, we ship so darn fast that what they looked at was 6 months old, right? Like, they that kind of thing. Like, those types of folks will want to be like, well, how do we rewire that process so that we know that we're not shipping software that we're not licensing, just as an example, versus, vulnerable stuff versus, stuff from other packages that are old or out of date. Like, all those problems surface because you're shipping so quickly and you're leveraging automation. You need to wrap all those supporting processes and think through them as if it was running. We're deploying 10 times a day. How painful would it be for the legal team to see this? Well, maybe we should just, in the CI/CD pipeline, go, oh, we'll ship off the bill of materials to them. And if they ever want to look, it's in the storage bucket. You know what I mean? And then they just show them, here, this is how you would look and check if you wanted to check. Because they're not really going, like, they're not going to have a lot of free-form queries, for example. So you sort of see that pattern, ask what they're using the data for, and go, hey, can I just send it to you in this place? And think through all those types of integration points. Like, that's why it's like forcing everybody to be that quick, where processes might take days or months, and those don't catch up. That's where you see that not meshing of the gears and abrupt conversations that are like, you're not doing it. You're doing it completely differently. You're not shipping the logs. And you're like, well, we're running this quickly. We're doing this thing because it adds business value. This is why we're doing this. We can ship features. Our customers are buying. This is why we're doing it. Y'all need to get on board. That's a little bit awkward as a conversation to say it that way, but basically that's what the business needs to do. It needs to mature all the supporting processes around it.
Awesome. And I love it. I feel like I can talk to you for hours about this, but I'm going to switch gears and switch to some of the questions that are coming in. And thank you for the patience, everyone as well, Vineet and Magno especially. I've got a question from Vineet over here. Which tools would you recommend for both attack and defense?
Kube Control, JQ, curl. That's dead serious, by the way.
Yeah. I was not smiling at all. Yeah, that's true. Without recommending any vendor out there, yes.
I'm a big fan of. So like, there's a couple things. Like if I'm attacking, there's Kubebench for CIS stuff. There's KubeHunter for penetration, light penetration testing stuff. There's Paratis. There's a couple others. I'm blanking on them, but there's some that are more attack or red team-esque. There's one that just came out that was mapped to the MITRE framework. That was kind of neat to see. But then there's like from the malicious activity detection, like this is one of those things that doesn't ship with Kubernetes. It's not part of its concern. Is what is running in that container good or bad? From the start or sometime after.
From a runtime perspective.
From a runtime perspective, exactly. I'm a big fan of the Falco project. Like that is, you can get a ton of value very quickly for a very inexpensive price. Just the price of being a member of a good community. That's what I would argue the cost of OSS is. It's not free. It's being a part of that community and helping and contributing back. But that gives you a ton of visibility into nefarious things that shouldn't be happening, and you'll want to add that to your defensive. If you're running something else, a paid or a vendor version, that's fine too. It's just something that's telling you that what's happening in this container is suspicious. You should take a look. Is huge. I mean that I don't want to say that's it, but like I tend to look at Kubernetes as a part of the whole. It doesn't exist on its own. It lives on some metal somewhere. It lives in some cloud somewhere. Has extremely tight integrations in a lot of cases. So it's not just Kubernetes. Just remember, it's everything. It's the VMs, it's the kernels, it's the components, it's the containers, it's what's in the container. All those layers of the stack typically require different tools or different perspectives. So it's an inventory problem first. So using standard cloud inventory tooling, standard posture management tooling to understand where all the things are. And then what's inside Kubernetes is building on top of that.
Awesome. Great answer as well. And actually, just on runtime, Magna had a question which was interesting for me. Besides eBPF, what other technologies do you think are important for protecting the runtime?
I mean, that's the new hotness. I shouldn't say new because it's been around for a while, but I would argue that in the last 2 or 3 years, it's seen a huge focus. There's a number of companies that are focusing solely on being really, really good at this. And I sort of, eBPF is like running kernel level code, but sort of in a sandbox. That's oversimplifying a little bit, but letting you plug in observability and security things of what's going on without having to write a kernel module is enabling that iteration to happen much more quickly and much more predictably across kernel versions and architectures. I see, runtime is a combination of what's happening in the container, how you're capturing what's happening if something goes sideways there, in combination with the logs that are being emitted from all the various log sources, from cloud APIs, from the API server, from the nodes themselves. Like that all goes into what is happening from a security perspective. So you kind of need to have all of that to be able to paint the complete picture.
That's awesome. I've got a few questions for Magnus, so I appreciate the patience as well. Yeah. What's next for Kubernetes security? Where should we focus on our efforts next?
I think it's tempting to say service mesh and identity and all that good stuff. From a risk perspective, it's still the hygiene. It's still the basics. I would argue as we get better with all those basics, like I said, like exposing API servers, no, we're not doing that. We're restricting layer 4. We're configuring and tuning our RBAC. It's not completely wide open and stars everywhere. And then we're implementing network policy and admission control, and we're doing basic things. We need to do that and do that well before we worry about sort of going up a level of maturity. That said, the one piece that is getting a lot of talk is software supply chain. That's because it's amplified in a containerized environment. It's literally like just empty nodes, like ready to run random software, let me know, and I will run it for you. So you have to think of like, well, where's all that coming from? That's sort of like pushing the risk to that part that's the hardest part, which is the OPSEC of all the humans and all the CI pipelines and all the build processes that make up all the dependencies of all the things that we build on top of and put inside of our containers. So like our focus should be like defenders should be do the hygiene, do the basics, do all those things really, really, really well. And then vendors and community focus on how we can make that supply chain visible and alertable that isn't completely alert fatigue. You know, like you scan a container for a vulnerability and you get 50 back and you can only patch 3 of them. You're like, cool, thanks. I can patch those 3, but I still have a glaring red dashboard that says, 47 unpatched vulnerabilities. Like that process needs a lot of empathy and a lot of love to make that effective, but it also needs a lot more detail and a lot more sophistication to be able to like make that process, get that risk balance for the cost in there.
I love the answer. And the wall of red is real for, even though both you and I are wearing red t-shirts, the wall of red is definitely real in a monitoring world.
Yeah.
I was going to say, it kind of begs another question to taking a leaf from there. For a security person to secure this properly, there's clearly a skills shortage as well, right? It's not that a lot of us came from a non-Kubernetes background and a lot of us picked up cloud. Now this new thing has come out like, oh, great, I've got to learn containers. Like, oh, I've started learning containers. Like, oh, great, now I have to learn Kubernetes as well. What else is next? And I think it's also coming from Magno's question, which I'll love for you to get into. But what are your thoughts on the skills conversation for Kubernetes?
I'll tell you what, like Kubernetes has built upon years, decades of abstractions. Linux, you have namespaces, you have bundled sets of processes with bundled the dependencies. You have this thing called a Docker container, now an OCI spec container, right? And then you have something that orchestrates them. So if you're learning and you start up here and you just assume, I'll just work on that stuff that's below it later, you're probably not going to be able to, from a security perspective, you're not going to properly develop your threat model. You're not going to know why. You might know what's happening, but might not know why it's like that or why it's configured this way or why that behavior is, unless you sort of understand Linux primitives, understand C groups and namespaces, and understand Linux networking, and all of those things build upon it. So if I were to say, like, where would you start? I would start at the start, which is not Kubernetes, not Docker, it would be all the way down just like, what is root? What is a user? What's isolation? What is the basic primitives of Linux before I'd start building on top of that. And as a Kubernetes security like focused person, the way I got to like and love and fall in love with Kubernetes is because I built with it. I had to operate it. It wasn't like I was just somebody else's cluster that I'm coming along to secure. I don't feel like you get enough empathy to know why things are that way. We ran a capture the flag exercise in 10 regions, 1 cluster per region, AWS in 2016 on Kubernetes 1.3 with Calico Alpha, right? We got really up close and personal. This is before RBAC. This is like service account tokens were mounted in every pod that were cluster admin by default. We had to work around that. We had to protect the metadata API with IP tables rules manually, like with the daemon set. Like we had to think of all those things to make a CTF environment. It's just like WordPress containers inside of a namespace, but like we had to think of all that multi-tenancy problem space and build it to understand it. So like I argue it's really hard to secure something if you haven't even at least deployed a couple apps and try to scale it, a couple replicas, and like, what if I change the image and like, oh, what if I can do that load balancer thing? Oh, the load balancer thing works. And then once you get it working, then start poking at it, then start breaking it, because then you'll go, okay, now I know the happy path. This is what they're trying to do. And I know why they're doing it this way. And then I can go, well, what if I did it the not correct way? Or what if I swept its legs out from under itself? What would it do? How does it behave? And I think that's where you have to be curious and be a builder a little bit to be able to say, I can attack or I can defend this. Because I think it's really hard if it's like your day job is to just be a defender and you've never looked or tried to deploy one of the apps that's running inside the cluster. That's very arm's length. It feels like you want to understand the workflow of the developers that are running stuff inside your cluster to be able to understand how to threat model it.
Interesting. And maybe that leads me to Magnus' question. What was your approach for learning it? And what would you have told your past self about how to learn Kubernetes?
Yeah, it was a team decision. This is 2016. It was between Mesosphere, and Kubernetes and Docker Swarm. And we kicked the tires on all of them. And the only thing that really worked the way that we wanted it to was Kubernetes. And we spent 9 months building this CTF platform to be able to run these events, right? And so it was an earlier time. It's hard to be like, yeah, it was easier, it was simpler times back then, but it really, really was. There wasn't much going on. You had pods, you had services, you had config maps and secrets and deployments, pet sets, not stateful sets. Like you had daemon sets that were like that. Those are your primitives. So it felt like you could understand all of those things. I argue going back to the roots is where I would start. I wouldn't start at service mesh. I would start at pod, service, deployment, config map, secret. I would go through the CKA, the Certified Kubernetes Administrator, syllabus, and really dive in as a builder before, and it's a prerequisite before the CKS, by the way, the Certified Kubernetes Security Specialist. You have to be a CKA first for good reason, because you can't secure what you don't know how to administer. Just get working, get running. It's very, very hard to do that. So that's what I would do. If I was like, my job, I started tomorrow and I had to be a Kubernetes security person, I would go do the CKA. And I know that's a lot. Like I would go to that track, whatever gaps I had to be able to get to that point, that's where I'd go first. And then I'd probably look at the syllabus for the CKS. And if I feel like sitting for it, sitting for it.
Awesome. So I guess learning Kubernetes the hard way, is that no pun intended there?
Yeah. Shout out to Kelsey. I mean, that repo has lived longer than I thought he would maintain it, but early on, it was incredibly useful. Here's why I think Kubernetes the hard way gets a kind of a weird naming rap to it, because it's actually Kubernetes the manual way, but it is quite possibly one of the simpler ways to do it manually. By that, I mean, set up these 3 nodes, download these binaries, make this YAML here or make this thing here, and start the service. Okay, move to the next node. Do the same thing for the kubelet on both of those nodes. You now have a Kubernetes cluster. That is quite, it's the tedious way, but it's actually pretty straightforward. It's like download a binary, put a config in and run it. That is enlightening. For a system administrator, a Linux sysadmin, they can grok that. I can guarantee you. They're like, oh, that makes perfect sense to me. I know what to do. Now it's just levels on top of that I have to learn. And I think that's the building block that a lot of people would really benefit from.
I definitely recommend that as well. So I'll add that to the show notes as well. So thanks for that question, Magno. Seems like we've been talking about technical things for a while, and yes. Did want people to know about your side as well, and what is Brad outside of all this. And I've got 3 fun questions for you.
Okay.
And not too many, just 3. And the first one is, what do you spend most time on when you're not working on Kubernetes or technology? Or pen testing? I'm going to throw that in there.
Professionally or personally?
You can pick whichever one you want.
Trying to be a good husband and a good dad. I think it's easy, especially in the work from home and the pandemic, to be like just working that extra hour because there's something on top of mind. I really, really try to like cut that time off at the end of the day, close the laptop and leave the office and be present, because you're not going to be here. Life is short, and I try to focus on that as much as I can. I will admit though to losing sleep, sitting up at night, like wife goes to sleep, I'm like, good night, honey. And then I'll just be like, I wonder how many megabytes per second you could send through a validating webhook. Like stupid things come into my mind. I'll write them down. I'll go to sleep, and then I'll think about them the next day, and I'll try to. But like that's I strive for that balance. It doesn't always happen, but that's really where you got to be at. Like getting ahead is success changes for you as you age. I think that's how everybody around me who I've like grown up with has also had some sort of revelation at some point where it's like, define your happiness and then go for that, because it's not necessarily Kubernetes security all day. That's a great job. It's a great thing, but that's not you. That's just something that you do and help others with. But happiness and success, define that yourself and go for it. But typically that should be, for me, that's focused on family and friends.
It's a great answer. And probably a good one for the next one as well. Then what is something that you're proud of, but is not on your social media?
That I'm proud of? that is not on my social media? I would say, I mean, aside from the family and the kids, like that is by far, I say aside from that, like after that, a deep, distant third is the friends in the community that is the cloud native, the Kubernetes community specifically. Like, I'm really proud of this community. I'm proud to be a part of it. And I just hope that it continues on, even if it morphs to another technology. The people that I've got to know in the past 4 or 5 years, it's like there's ride or die crew in there. Shout out to Sig Honk, like Pop, Magno, like all these people that I keep seeing and keep interacting with. It's almost always overwhelmingly positive and helpful. And I just want to give back as much as they have given.
That's awesome. Great answer as well. And I can definitely vouch for at least most of the people that I'm talking to in cloud native space definitely seems to be a great bunch to hang out with in person as well. So hopefully I can do that one day with them.
Yes, I would love to.
Last question. What is your favorite cuisine or restaurant that you can share?
There's a great, there's a great Thai place near me that we just love, and they deliver in like 22 minutes to the door. It's unreal.
Oh, really?
Thai. Yeah. It's a guilty pleasure, no question. I do enjoy Mexican food anywhere. Like I will go Mexican anytime, anywhere. But there's a chain of restaurants here that's called Great American Restaurants, like a Sweetwater and a Coastal Flats. Always a quality meal. So if you ever come to Virginia, Northern Virginia, I'll take you out to one of those places and get a really great burger for cheap.
I'm looking forward to that one. Awesome. Well, that's pretty much what we have time for. And before we kind of drop off the live stream, I wanted to kind of, I guess, let you share a piece about where you normally hang out for people to kind of reach out to you, ask any questions. Like, what are your socials that where you normally hang out?
Yeah, I mean, my DMs are open unless I get some riffraff. But everybody who's hit my Twitter, it's at Brad Geesaman on Twitter. I'm also B Geesaman on GitHub, although that's not really as social. But I'm also Brad Geesaman on LinkedIn. There's only one other Brad Geesaman that I'm aware of that's on LinkedIn. So I'm easy to find because I use my name everywhere. So shout out with reach out with DMs or questions. I'll get back to you as soon as I can.
Awesome. And thank you so much for coming on board. And I had a great time. As I was saying, I had a lot more questions and I didn't go through all of them, but this was totally worth it. And I hope to have you once again, at least to talk about more things that we can be doing in Kubernetes security. But I will look forward to talking to you again soon, Brad. But thanks so much for this. And for everyone else who's tuned in, thank you so much for joining us as always every weekend. And next weekend, we're switching another topic and moving on to bug bounty and Google Cloud Security. You'll get to know a bit more as we kind of go through this in the week. So that next month is focused on that. And if you want to know more about this and a lot more on the topics that we talk about, feel free to subscribe and follow on whatever platform you're watching this on. And thank you, Brad. And thank you everyone else for coming in. Thank you.